Oh, this sample problem we're going to work out step by step involves an inelastic collision just in one dimension. From the drawing you can see we have 0.3 kilograms of clay moving left at minus 6 meters per second. I'm choosing to have east, to the right here, be the positive direction. In problems you need to be sure you're clear on what direction's positive, what direction's negative. Our second lump of clay is 0.8 kilograms, 9 meters per second, towards the east. These two are going to hit and stick together. Clay, soft clay, they're sticky, and it's an inelastic collision. We're going to have one object after the collision. They're moving horizontally through the air, and we're only going to worry about the horizontal part of the motion. We're not going to discuss how gravity is pulling the objects down. We're going to do this calculation just centered right on the collision time and not worry about gravity giving some momentum downward. This is a horizontal calculation. We want to know what is the velocity of this 1.1 kilogram lump of clay in the horizontal direction. Not worried about vertical motion. And we want to know if kinetic energy is conserved. Well, summarizing the data is always good to do. Make a drawing. Is momentum conserved in the horizontal direction? Well, in the air, we're going to ignore air resistance. There really is no external force on the objects in the horizontal direction. Force of gravity is vertically downward. It's not horizontal, doesn't have a horizontal component. So we have no external force acting on the two objects. Momentum will be conserved when there's no external force. The collision impact, there is force occurring during the collision, but it's an internal force, and it has no consequence in altering the value of the momentum. So momentum is constant. Momentum is conserved. We have no external force in the horizontal. Well, what do we have for a velocity? Because momentum is conserved, we can create an equation calculating momentum before the collision and equating it to momentum after the collision. Before the collision, there are two objects. The smaller clay has a negative 6 meters per second for its velocity. It's important you carry that minus sign along the calculation. Its momentum is a negative quantity. Momentum is a vector. It can be positive or negative. And the 0.8 kilograms gives us 7.2 kilograms meters per second for its momentum, positive. The net of these two, the momentum of the system of the two objects, is 5.4 kilograms meters per second. After the collision, we don't know what the number is for the momentum, but we can write an expression. That expression is the mass times the velocity that's unknown for just a little bit. So I equate these two. 5.4 kilograms meters per second before the collision for the momentum equals 1.1 times v after the collision. Pull out your calculator, do a little division here. I came up with 4.91 meters per second. A positive number tells me that the 1.1 kilogram object is moving towards the east. It dominates in this collision. What about kinetic energy? Is the kinetic energy conserved? 1/2 mv squared for the kinetic energy calculation. Make sure you do remember to square your velocity. We have two objects before the collision. The 1/2, the mass, minus 6 squared. That produces 5.4 joules for the result of the calculation. For the second object, it's more massive and it has a bigger magnitude of the velocity. So we end up with more kinetic energy from that object, 32.4 joules. Our system has a kinetic energy before the collision, 37.8 joules. After the collision, 1/2 mv squared, the 4.91 meters per second on the previous slide, and I see 13.3 joules after the collision. And as we expect, because this is an inelastic collision, kinetic energy is not conserved. When objects stick together, when there's some inelastic nature to the collision, energy is not conserved. We won't worry about where it goes to. You can ask your instructor about that. I have a list of my YouTube videos. They're organized by topic. by the physics concept or astronomy concept, and some miscellaneous as well. And the list is annotated. There's a title, there's how many minutes the video goes, there's the description of the video, and there's a link direct to YouTube. You don't have to search on YouTube for my videos. You can click on that link and you'll be watching the YouTube video. All the content is free. You don't register or give your name or email address. And my website does not put cookies on your computer. Keep working physics problems and be sure to ask your instructor when you have questions.